Do you sometimes think that regular expressions look just like a cat walked over your keyboard? Well, my name is Benjamin from regexland.com, and if you give me about 10 minutes of your time, I can teach you how to use regular expressions. The tool I'm using here is regex101.com, and it's a really great tool to help you to understand your expression a little bit better and also to see which part of a test string is matched by your expression. So here the test string I have is the fourth man ran over the can in the rain to get to the fifth pan. Makes no sense at all now, but you'll see in a minute why it makes sense. So we can start by entering a regular expression here at the top. For instance, say I want to match the word man. I just type in man, and this is a literal expression in that it literally matches the word man. I can also match the word ran just as easily, but let's say I want to match both of these. So I can enter man and a pipe character and ran. So this will match both man and ran. I can add others as well. Let's say can and also pan to match all four of these words at the same time. But this is getting a little bit long-winded, so there's an easier way to do this with a character range. A character range is enclosed in square brackets, and it matches any character inside the square brackets. For instance, I can type here M or R followed by AN. It means that it will match man and ran because the first character can come from either M or R, which are the two characters enclosed in the square brackets. I can also add others in here like C for can and P for pan, and all of them will be matched. I can also turn this into a negated character set. Let's say I want to match any three-letter word ending in AN, but not starting with C or P. So if I insert a caret symbol here at the front of the character range, it will match any three-letter word ending in AN, not starting with C or P. So it won't match can or pan here at the end, as you can see. Character ranges are really fun in that we can insert something like A to Z, which means that it will match any letter from A to Z. We can also do capital letters like A to Z, which means now it will match all the lowercase letters followed by AN, but also the uppercase letters like man or pan. We can do digits like 0 to 9, and in this case it will even match 0AN and 5AN. And we can even, if we really want to get fancy, we can add some symbols like a hash or a percentage sign, and this will match hash AN and also percentage AN. Now once again, this is getting a little bit long-winded, so how about we just delete this whole thing and replace it with a period symbol. A period symbol matches any character, as you can see by hovering over it, so it will match any letter, number, or special character followed by the letters AN. Special characters are special character ranges in that they specify a specific type of character. They start with a backslash followed by a letter. For instance, the S special character matches all spaces, as you can see by those highlighted. The capital S matches everything that is not a space. The D character matches all digits. Capital D matches everything but a digit. W matches any word character, which you can see over on the right hand side is any lowercase and or uppercase letter, any number, and also an underscore. While the capital W, you've guessed it, matches anything but a word character. So it'll match all the spaces and all the special characters here. Next up is quantifiers. We need 2 of these, 3 of these, and lots of these. Quantifiers help us to specify how much of a character we want to have matched. For instance, let's type the word rain. You can see it matches the word rain, but let's say I want this I to be optional. I can do that by simply inserting a question mark behind I. And note that the quantifier acts on the character right in front of it. So this is telling me that the I must be optional. So in this case, it matches both ran and rain, either with the I or without the I. Another quantifier is the plus symbol, which if you hover over it with your mouse, you can see matches between 1 and unlimited times. So it'll match the preceding character, the A, 1 or unlimited times. So it'll match 1, 2, 3, 4 up to infinity. Another quantifier is the asterisk, which will match 0 or more. So it'll match all of these, and it'll also match 0 instances of A, which only leaves Rn. If I want to match an exact amount of a character, for instance, let's say I want to match 2 A's, I can change this to curly braces and insert a 2 between them to show that I want to match exactly 2 A's. This will not match 3 A's, it won't match 1 A, it'll match exactly 2 A's. If I want to match between 2 and 5 characters, I can do so as indicated. So this will match 2, 3, 4, 5, but not 6 A's. Let's say I want to match 2 to infinity. I can do that by just deleting the 5 here, and this will match any number of A's from 2 up to infinity. Next up we have anchors, which will help us ensure that a match occurs either at the start or at the end of a string. Anchors are a great way to ensure that the match returned is at the start or the end of a string and that there's nothing in front or behind it. For instance, let's type the word the. You can see that it returns 4 instances of the word the, but let's say I only want the one right at the start of the string. I can do that by inserting a caret symbol at the start of my expression, and now you can see it only returns the at the start of the string. If I insert a space here, you can see that the is no longer at the start of the string, and thus it is no longer matched. The corresponding character for the end of a string is the $sign. So let's put the $sign right at the end. And now it won't match any instances of the word the except the one right at the end. Captured groups is a great way to extract a part of a match. For instance, let's say I want to match a digit followed by th. So this will match both 4th and 5th. And if you look over to the side here, you can see the matches here, 4th and 5th, and these are all full matches. But let's say I only want to match the 4 or the 5. I can do that by enclosing the digit symbol in parentheses, which indicates that this is a capture group. And as you can see now on the right, it will match 4th and 5th, but it will also extract the 4 and the 5 from each of these. I can also include other capture groups. For instance, if I want to extract H here at the end, and it will extract H in each of these, which are the same for both cases. If I want a group to act as a group, but I don't want to extract it, I can just insert a question mark and a colon at the front of a group to turn it into a non-capture group. This is a great way, for instance, if I want to match H or I in this position, but I do not want to return this group. The great thing about regular expressions is that you combine all of these strategies to form a really complicated expression. For instance, let's say I want to match a digit followed by a word character. Let's make that 0 or more word characters, followed by a space, followed by the word man. But let's say I want to change this M to match both M and P. So this will return 4th man and 5th pan. But let's say I only want to match the one right at the end of the string, so I can insert an anchor right at the end of the string, a $sign to return only the one at the end of the string. These can get really complicated. For instance, this is an expression that matches a date. The date is in the format of a 4-digit year, a 2-digit month, and a 2-digit day, all separated by forward slashes. And as you can see here, the year is a capture group, the month is a capture group, and the day is a capture group on the side here. Now, this expression is smart enough to know that a date greater than 31 is not allowed. For instance, if I type 35 here, it will not be returned. And now that you've tied that keyboard cat to a leash, I hope you understand a little bit more about regular expressions. For more information, visit regexlan.com and please like and share this video. Thanks for watching.